Alrighty, moving on to example number 2. So this question is going to use the distributive property in combination with variables on both sides. So I'm going to attempt to fit this all on one screen, but I bet you when it's all said and done, I'll have to erase and do a second part. So I'm going to start out by writing this just a little bit bigger because it's really hard for me to work with tiny little numbers. Poof, there we go. And looking at this, I noticed that I've got some parentheses. So whenever I see the parentheses, that tells me that I'm going to have to take care of those first because that's what we always do when we think about pandas. So we're going to use what we call here at Kikianga the cherry bomb method to get rid of these parentheses, but it's also really known as the distributive property. So we've got -2 times x, and that's equal to -2x. And then we've got -2 times -5, which becomes a +10. And then when I get over to the other side, I've got, again, that 6 that needs to be distributed. So I'm going to distribute it or cherry bomb it. So when I multiply 6 times 2, I get 12. And to multiply 6 times the fraction -1/2, I'm going to want to think of 6 as 6 over 1. And then I'll multiply that times the -1/2. So when I multiply across that top, 6 times -1, which is -6. And across the bottom, 1 times 2 is 2. And let's move me out of the way so we can finish this. So when I simplify this, these are both divisible by 2. So -6 divided by 2 would be -3. And 2 divided by 2 would just be 1. So I'm going to call that a -3. And then there's an x behind it, so -3x. Okay, on to step 2. So now I'm going to look at my problem, and on both sides of the equal sign, I see some variable terms which have letters, and I also see some constant terms with no letters. So I just want to identify those so that your eyes can see it, and I'm a very visual person, so some of you might like this. I'm going to do what I call shape coding. So I call this shape coding because I'm going to use different shapes on the different types of expressions. So I'm going to start by giving my variable terms with an x attached to them a circle, and I happen to choose yellow. So I'm going to circle my variable terms in yellow. And I noticed too that on each side of the wall or the equal sign, I've got some constant terms that are just numbers without letters. So I'm going to give those a different shape. Like I said, I call this shape coding. So I'm going to give them like a triangle. Actually, let's do a rectangle. It'll probably fit better to save some space since I'm trying to write tiny. So I'm going to give them a pink rectangle. So now when I look at this, I see that I've got variables, yellow circles on both sides, and I've also got constants on both sides. So my ultimate goal is that I want to move all of my variables to the other side and all of my constants over to the right side. And it doesn't necessarily have to be that way, but as a mathematician, I like to try as much as I can to get my variable on the left. So I'm going to start out by taking -3x, and I'm going to cross it over to the other side. So if I want to get rid of -3x on this side, the way that I would cancel that out is by doing the inverse operation. And the inverse operation of -3x is to add 3x. So I'm going to add 3x to this side. And if I add it to one side, then I have to add it to both sides in order to keep it balanced. So that will allow me to cancel my 3x out over here on this side. But on the left side, I'm going to have to simplify. So I've got a -2x plus a 3x. So that ends up being just a +1x. So I can just call that x and x. And then I'm going to bring down the rest of my terms. And I'm also going to bring down, and I can already tell that I'm running out of room. So I'm probably going to be erasing to show some more steps. But now we can see that we've got all of our variables, all of our x terms just on the left side. There's no more left over here on the right. But we also have this constant 10 that we need to move to this side. So in order to move that across to the other side, we're going to have to cancel out +10, and the opposite or inverse operation of +10 or +10 is to subtract 10. So we're going to subtract 10 from both sides in order to keep it equal. So that will cancel out the 10 on this side, the left side. And now I need to simplify 12 minus 10, which leaves me with just 2. So x is equal to 2.